the slide 11 timeline. First, I will introduce about our topic and case study. Soil enhancement and stabilization methods are a collection of techniques and approaches designed to improve the soil engineering characteristics for different construction and infrastructure in the field. On the contrary, stabilization methods aim to prevent soil erosion, minimize settling, and manage factors such as moisture level and soil pH. We have selected the Genting Highlands and Bani project as focal points for our in-depth exploration for soil improvement and stabilization techniques. This project provides rich case studies for investigating diverse methods and strategies used to enhance soil quality and stability, particularly within the realm of extensive construction and infrastructure in the world. Next, for background and parties involved of Genting Highland Project. The title of project is Cadangan Pembangunan Bercampur Bersarta dan Berfasa yang mengalami plot 1 fasa 1A dan plot 1 fasa 1B. Di atas sebahagian lot 103-3, Genting bermain mungkin bentung daerah bentung Pahang Darul Makmur bagi Tuan Zintiadi Development Sdn Bhd. For the client, is Tuan Zintiadi Development Sdn Bhd, developer Zintiadi Development Sdn Bhd, and engineer SNA Consulting Sdn Bhd. Last but not least, the main contractor is Johan Sdn Bhd. Next, for background and parties involved of Bani project. The title of project is Cadangan Merabur Gerai dan Medan Sdn Diada dan membina medan niaga Komiti 1 terkait atas lot 30004 dan 3005 Seksyen 16 Bandar Baru Bani, Mukim Kajang, Daerah Hulu Langat Selangor Darul Ihsan untuk Majlis Penerangan Kajang. The client for this project is Majlis Penerangan Kajang and project manager and company is Muhammad Nuri Rahim, Sinar Setara Resources Sdn Bhd. Next, I will exemplify about type of soil and its properties for Genting Highland project. For soil classification, known for its DC clay soil which possesses specific challenges and properties for agricultural activities and construction. The clay soil in this area is a result of weather processes affected by the tropical climate and abundant rainfall. For physical and chemical properties, physically characterized by its fine grain texture, high water retention capacity, and low permeability. For chemical, the soil often contains a high content of iron and aluminum oxides, which can give it a reddish color. The pH level of the soil tends to be acidic. Next, for its geotechnical properties, the clay found in Genting Highlands exhibit high compressibility, low shear strength, and a tendency for substantial settlement under load. Last but not least, for its soil testing result, Genting Highlands is usually subjected to a series of laboratory and field tests to assess its characteristics. Results of these tests consistently indicate high plasticity, low permeability, and moderate to high compressibility, highlighting the need for meticulous engineering practices. Next, for Bani project, soil classification. The kind of soil found in Bani project is clay soil. This region soil is often classified using the Unified Soil Classification System, which divides clay soil into two categories, which is CH clay and CL clay, depending on the plasticity index of the soil. For its physical and chemical properties, physically, clay soil has a fine texture and depending on the particular material present, can range in color from reddish brown to green. Chemical, kaolinite, illite, and marmorilite are among the clay materials that make up a large portion of a clay soil. Next, for its geotechnical properties, low permeability results in slow water drainage, potentially causing water clogging and stability concern in construction projects. The high plasticity and shrink swell behavior. Clay of clay soil can create corrosion issue if not effectively addressed using methods such as soil stabilization or moisture control. Soil testing result includes the evaluation of different factors such as moisture content, compaction, shear strength, and permeability. The finding from the test assists engineers, builders, and farmers in implementing suitable strategies to address the challenges associated with clay soil properties. Next, for soil improvement and stabilization techniques for Genting Highland Project. The Genting Highland Project, a notable engineering project, uses cement grouting as a primary technique for soil stabilization. Cement grouting entails injecting a cement-based mixture into the soil to fill gaps, build loose soil particles, and establish a more unified and stable soil structure. The decision to use cement grouting in Genting Highland was based on the specific geological challenges in the area, including loose or fractured rock and soil. In the Genting Highland project, comprehensive geotechnical survey were carried out to evaluate the soil properties and pinpoint the area in need of stabilization. Next, for soil improvement and stabilization technique for Bali project. Different from Genting Highland project, Bali project used soil compaction. Soil compaction has been a crucial factor in the Bali project for the preparation of the ground for constructing infrastructure. The soil compaction process includes multiple steps, beginning with evaluating soil properties. Next, appropriate machinery is selected based on soil type and project needs. Then, the soil is then spread in thin layers called leaf and compacted individually.
Hi and Assalamualaikum. My name is Nur Zahida. Will be continue to present about the equipment and machinery used in the Genting Highlands project and Banis project. As per mentioned from Irina, the types of soil improvement that implement for Genting Highlands project is cement grouting and compaction soil for the Banis project. As what site manager said, the equipment used for the Genting Highlands consists of grouting mixing equipment, grout pumps, and grouting accessories equipment. Let's begin with the grouting mixing equipment first. Grout mixers is very important to prepare the grout mixture to be used as the material for grouting. During the process, we need to combine cement, water, and some of the additive to enhance the properties of the grout using this equipment. With the powerful motors and blades, we will producing a smooth and even grout mixture. Next is grout pumps. The function is to pump the grout mixture into the ground under high pressure to ensure the grout penetrates well into the soil or rock fissures. Lastly, grouting accessories such as injection, packers, hoses, and valves. With the completed of accessories, it will help to improve the process of soil improvement and control devices to ensure precise and effective injection. For the buggy side, they use vibratory roller compactors, sand bedding, and plate compactor machine. For the compaction process, we must use vibratory compactor to roll over the surface and providing high compaction energy. The vibrations also help rearrange the particles closer together, reducing voids and increasing soil density. So, it will make the soil more stable and suitable for supporting heavy structures. Second, they use sand bedding that involves a layer of sand on the base of an excavation or trench to create a smooth, level surface. The sand provides a stable and uniform bedding that helps distribute loads evenly and prevents points load that could damage the installed utilities. Lastly, plate compactor machine to compact the material by forcing the particles closer together, also reducing air voids and increasing density. From that, it will provide a uniform base for structures. Next is the quality control measures during the construction. Pre-construction preparation. First, do the soil investigation. Test soil properties like grain, size, moisture, and Atterberg limits. Use finding to plan grouting and compaction. Next is monitoring and testing during construction, which are grouting by monitor pressure and flow rates to ensure uniform injection and prevent over-pressurization. Also do the grout mix to test viscosity, setting time and strength regularly to meet design criteria. After that, do the compaction control and testing by using equipment to calibrate and maintain compaction equipment for optimal performance. Next equipment is moisture content to manage soil moisture to achieve proper compaction. After that, implement the quality assurance measure by doing the density test to verify soil density with tests like sand, cones, or nuclear density gauge. Next is load testing to assess soil strength through load test post-compaction. Lastly, do the documentation and supervision by record keeping the document all quality control data including routing details, equipment calibration, and test results. Next is supervision to ensure consistent oversight to maintain project standards and address any deviation. Move to the testing and monitoring procedures that implement for both sides. For the Genting Highlands site, there are 3 stages of testing: pre-improvement testing, on-site monitoring testing, and post-improvement testing. For the pre-improvement testing, by doing the soil investigation to test soil properties like rain, size, moisture, and attribute limits using boreholes, drilling, SPT, and CPT. Next is permeability testing to conduct constant head or falling head test to assess water transmission in soil. After that, shear strength testing is to perform direct shear, triaxial, and compression tests to evaluate soil stability. For the on-site monitoring during testing is ground injection pressure by monitor pressure to ensure effective void filling without damage. Other than that, flow rate measurement to measure ground flow rate for uniform injection and distribution. Ground mix consistency also to check viscosity, density, and setting time to meet design requirements. Next is post-improvement testing is core sampling to drill and analyze cores to assess ground distribution and strength. Standard penetration tests also conducted to evaluate soil density and strength changes due to grouting. Cone penetration test is to measure soil resistance to penetration to assess improvement. We move to the Bangi site test and monitoring procedures, starting with pre-improvement testing that consists of soil sampling to collect soil samples from various depths using boreholes or test pits. Next is grain size distribution analysis to perform sieve and hydrometer tests to understand soil gradation. Lastly, compaction characteristic is to conduct Proctor tests to determine compaction parameters. For the on-site monitoring during testing is Proctor compaction test that will determine optimal moisture content and maximum dry density of compacted soil. Plate load test also conducted to evaluate bearing capacity and settlement characteristics of the soil. Vein shear test is to measure the shear strength of cohesive soils to assess compaction effectiveness. For the post-improvement testing is plate load test to confirm soil bearing capacity and settlement post-compaction. One penetration test also conducted to assess soil density and strength using continuous penetrometer data. Standard penetration test is to determine soil density and strength through blow count analysis. That's all from me. Thank you.
Assalamualaikum, my name is Nur Aimani Huda binti Azmi and I will be presenting about the problem and solution for both projects. In Genting Highlands, the primary issue with clay soil are its high plasticity, poor drainage, and presence of voids. The soil tendency to swell and shrink with moisture changes leads to landslide and structural instability. Poor drainage exacerbates this problem, especially during heavy rain. Hidden voids and fractures in the soil further compromise the foundation stability. Additionally, heavy rain causes soil erosion, damaging the landscape and ecosystem, while the acidic nature of the soil limits plant diversity. To address this issue, we use lime and cement stabilization to reduce plasticity and increase soil strength. In severe cases, we replace problematic clay soil with more stable materials. Cement grouting fills void, stabilizing the ground. For erosion control, we establish vegetative cover and use terracing and erosion control blankets. To neutralize soil acidity, applying lime and incorporate organic matter can improve soil health and plant diversity. In Bangi, the main problems are poor bearing capacity and susceptibility to compaction. Clay soil here struggle to support structural loads, leading to uneven settlement and potential damage. The soil becomes hard and compacted when dry, reducing water absorption and increasing runoff. When saturated, it becomes soft and unstable, risking subsidence and foundation instability. Now, to tackle this challenge, we use lime and cement stabilization to enhance soil strength and reduce plasticity. Deep compaction technique increase soil density, and in extreme cases, we replace unstable clay with robust material like gravel. precise compaction method ensure optimal soil condition, while effective draining system manage water infiltration, maintaining soil stability, and preventing saturation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdana Betisha binti Muhammad Taufik, and today I will present about the recommendation for improvement, suggestion for Genting Highland in enhances effectiveness. Firstly, is about advanced solution for geotechnical engineering, which is these techniques increase soil support and resistance to movement, which is deep foundation can shift structural load to stable soil layers or bedrock. Next is monitoring and early warning system, which is early warnings of landslides and settlement problem via these technologies. And this is proactive strategy for controlling dynamic behavior of clay soil in the region. And lastly is sustainable construction practices, which techniques include terracing, retaining walls and plant cover for soil anchoring and halting topsoil loss. And these procedures ensure long-lasting, stable project and environmental protection. Next is suggestion for Bangi in increasing efficiency. First thing is advanced soil improvement techniques in decrease clay soil flexibility and increase their bearing capacity. It improves soil structural qualities and making it capable of bearing large load. And lastly is efficient drainage and water management system, which effective drainage and water management system are crucial for consistent moisture content. Drainage system prevent water build-up, reducing soil softening and swelling hazards. Next is ideas for cost reduction. First is efficient resource usage, which is use locally sourced good, bulk purchasing and standardized design. Next is sustainable practices, which is recycling and reusing materials and energy efficient designs and renewable energy. Third is about workforce efficiency, which is training programs and automation of repetitive tasks. And lastly is about risk management, which is comprehensive site investigation and contingency planning, early stakeholder participation and clear communication. Next is similarities and differences between Genting Highland and Bangi's project. This table contains aspect, the objective, soil improvement and technique, equipment and machinery, end goal, specific condition, quality control measurement and similarity between Genting Highlands and Bangi project. Next is effectiveness and efficiency comparison in Genting Highlands project. For effectiveness, contains strength and stability and targeted improvement, which is the routine process allows for targeted soil improvement, addressing specific problem areas identified during soil testing and characterization. Lastly is efficiency, which is contains process duration, resource intensive and adaptability. For Bangi project, the effectiveness is about density and settlement and uniform improvement, which is the use of sand bedding and systematic compaction ensures a uniformly stable base, which is critical for preventing differential settlement and providing a reliable foundation for construction project. For efficiency is about process duration, cost effective and simplicity, which is the straightforward nature of the compaction process makes it easier to implement. Lesson learned from both projects is about site-specific requirements, which is through soil testing and tailored approaches. Next is planning and preparation in efficient site preparation, which is use suitable machinery and planning for optimal results, and pre-construction assessment, which is identify obstacles and tailor plans accordingly. Third is about efficient use of machinery. In Genting Highlands, we use specialized equipment like grout, mixers and pump, and Bangi vibratory rollers and plate compactor for uniform compaction. Lastly, it's about monitoring and quality control, which is Bangi field density test and moisture content control, and Genting Highlands real-time monitoring and post-injection testing.